In Level 3, we will be solving more difficult distance and midpoint applications, including the concept of a perpendicular bisector. Looking at example 4, it says write the equation of the perpendicular bisector to the line that contains the points A, 8, -3, and B, 0, 7. Write the answer in point-slope form. A perpendicular bisector to a segment, if we have a segment AB with coordinates 8, -3, and 0, 7, its perpendicular bisector is a line that bisects it at a 90-degree angle. Bisecting a segment means we cut it in half, right down the middle, so we find its midpoint, and then we need a line perpendicular to the line, so it cuts it in half and makes a 90-degree angle with the line. And we want to write the equation of this line. So the first thing we need to find is that middle point right here using the midpoint formula. So finding the midpoint of AB, we add together the x's, 8 plus 0, divide by 2, add together the y's, -3 plus 7, divided by 2, and 8 divided by 2 is 4, 4 divided by 2 is 2. We get the coordinates 4, 2. So that's the coordinates of the midpoint of the segment. Now we need the, to write the equation of this perpendicular line, we need its slope. So first we need to find the slope of AB. Remember, the slope formula is y2 minus y1 over x2 minus x1. So we subtract the y's on the top, 7 minus -3, subtract the x's on the bottom, 0 minus 8, which is 10 over -8, or -5 over 4. Now, this is the slope of the line AB. But we want the slope of the perpendicular line, so the perpendicular slope is going to be the opposite reciprocal of that. So I flip the fraction and change the sign. So that's going to be positive 4/5. And now to write the equation in point-slope form, which is y minus y1 equals m times x minus x1, I use the perpendicular slope and the midpoint of AB, and that will give me the equation of the perpendicular bisector. So it's going to be y minus the y-coordinate of the point, which is 2, equals the slope, 4/5, times x minus 4. And that's the equation of the perpendicular bisector. This next example is another application of the distance formula. We want to find the point on the x-axis that's equidistant from the points 7, 8, and -2, 10. First, let's draw a diagram of what this will look like. The point 7, 8 is in quadrant 1, and -2, 10 is in quadrant 2. And we want a point on the x-axis that's equidistant from those 2 points. So some point on the x-axis, I'm not sure where it is, that is the same distance from those 2 points. Now, the coordinates of that point on the x-axis, I don't know the x-coordinate, but I do know the y-coordinate of every point on the x-axis. Anytime you have a point on the x-axis, it has a y-coordinate of 0. So there's some x value we don't know, but the y-coordinate is 0. So what I want is the distance from the point -2, 10 to x, comma 0 to equal the distance from 7, 8 to x, comma 0. So I set up an equation using 2 distance formulas. So the distance I use the distance from negative 210 to x 0, so I subtract the x's. I get x minus negative 2, which will be plus 2 squared, plus the y coordinate is 0 minus 10 squared, and I set this equal to the distance from 7, 8 to x 0. So again, using the distance formula, x minus 7 squared plus 0 minus 8 squared. And this is an equation I can solve. I can get rid of those radicals by squaring both sides. That will cancel the radicals. And I can also simplify here and here. So I get x plus 2 quantity squared plus negative 10 squared is 100 equals x minus 7 quantity squared plus negative 8 squared, which is 64. To solve this equation, it's quadratic. I'm going to have to multiply this out and get all my terms to one side. So x plus 2 squared, x plus 2 times x plus 2 gives me x squared plus 4x plus 4 plus 100 equals, and then I have to do x minus 7 times x minus 7, and that gives us x squared minus 14x plus 49 plus 64. If I subtract x squared from both sides, my x squared terms are actually going to cancel out, and I get all my x's to one side. I'm going to get my x's on the left side by adding 14x to both sides, and that gives me 18x. And I'm going to get all my regular numbers to the other side, and that gives me 9. So I divide both sides by 18, and I get x equals 9 over 18, or x equals 1/2. So the coordinates of the point that would be equidistant from those 2 points on the x-axis would be 1/2, 0.